For centuries, humanity has gazed upon the Milky Way, a river of light arcing across the night sky. This celestial phenomenon has been a source of wonder and inspiration, guiding explorers and sparking the imaginations of poets and scientists alike. The Milky Way, with its dense clusters of stars and ethereal glow, has always been a constant in our night sky, a reminder of the vastness of the universe. We understood it as our galaxy, a vast collection of stars, gas, and dust. This immense structure, spanning over 100,000 light-years, contains billions of stars, each potentially hosting its own planetary systems. The Milky Way is not just a backdrop to our night sky, it is a dynamic and ever-changing entity, with stars being born and dying and cosmic events shaping its structure. Our place within it seems self-evident. Nestled in one of its spiral arms, our solar system appeared to be just one of many, a small but significant part of this grand cosmic tapestry. The idea that we were part of something so vast and intricate was both humbling and awe-inspiring. Our solar system, a sun orbited by planets and other celestial objects, was thought to have formed within the Milky Way. This belief was based on the observation of similar systems within our galaxy, leading us to conclude that our origins were not unique, but part of a common galactic process. This understanding painted a picture of a relatively peaceful cosmic existence, a cradle for our existence. The Milky Way was seen as a nurturing environment, providing the necessary conditions for life to develop and thrive. It was a comforting thought, one that made our place in the universe feel secure and stable. The sun, our life-giving star, seemed eternally bound to this galactic home. Its steady presence and the regularity of its cycles gave us a sense of permanence and continuity. The idea that our sun had always been part of the Milky Way was deeply ingrained in our understanding of the cosmos. Like children assuming their home is the center of the universe, we held this belief for generations. It felt comforting, it felt intuitive. The Milky Way was our cosmic neighborhood, and we were its inhabitants, looking up at the stars with a sense of belonging and wonder. The Milky Way, our galaxy, was where we belonged. It was our home in the vast expanse of space, a familiar and reassuring presence in an otherwise mysterious universe. The idea that we were part of this grand structure gave us a sense of identity and place. However, the universe holds many secrets. As we delved deeper into the mysteries of the cosmos, we began to uncover evidence that challenged our traditional views. The more we learned, the more we realized how little we truly understood about our place in the universe. As our understanding of the cosmos evolved, so too did our understanding of our place within it. New technologies and methods of observation allowed us to peer deeper into space and time, revealing a universe far more complex and dynamic than we had ever imagined. New discoveries challenged the long-held belief in our solar system's Milky Way origins. Evidence began to emerge suggesting that our solar system might have had a more tumultuous and dramatic history, possibly involving interactions with other galaxies or cosmic events that reshaped its formation. The universe, it seemed, had a more dramatic story to tell. Our understanding of the Milky Way and our place within it was just the beginning. As we continued to explore and learn, we uncover new chapters in the cosmic narrative, each one more fascinating and complex than the last. The story of our galaxy and our solar system is far from complete, and the journey of discovery continues. Advances in astronomy brought forth the tools to study the universe in unprecedented detail. These tools, particularly the high-powered telescopes, have revolutionized our ability to observe the cosmos. No longer are we limited to the naked eye or rudimentary instruments. We now have the capability to explore the farthest reaches of space with remarkable clarity. Powerful telescopes allowed us to peer deeper into the cosmos, uncovering clues about the distant past. These images, often breathtaking in their beauty, reveal the complex and dynamic nature of the universe. Each photograph tells a story of cosmic events that occurred millions or even billions of years ago, offering a glimpse into the history of the universe. With these tools, we began to unravel the intricate dance of galaxies, their movements, and their interactions. Galaxies are not isolated islands in space, they interact with one another in a cosmic ballet, influenced by gravitational forces. These interactions can lead to spectacular events such as collisions and mergers, which play a crucial role in the evolution of galaxies. The traditional view of a static, unchanging universe crumbled away. We now understand that the universe is in a constant state of flux, with galaxies moving, colliding, and merging over time. This dynamic vision of the cosmos has transformed our understanding of the universe's history and its future. It was replaced by a dynamic vision of cosmic evolution, a universe shaped by collisions, mergers, and transformations on a grand scale. These events are not rare. They are a fundamental aspect of the universe's ongoing development. Each collision and merger contributes to the formation of new structures and the redistribution of matter and energy throughout the cosmos. Evidence began to mount, suggesting our solar system might not be a native of the Milky Way after all. Astronomers have discovered unusual star patterns and other anomalies that hint at a more complex history for our solar system. These findings challenge long-held assumptions and open up new possibilities for understanding our place in the universe. This evidence pointed towards a dramatic event in the Milky Way's history, a collision with another galaxy. Such a collision would have had profound effects on the structure and composition of the Milky Way, potentially altering the orbits of stars and other celestial bodies within it. This wasn't just a glancing blow, but a significant interaction that left an indelible mark on our galaxy's structure and evolution. The collision would have triggered waves of star formation, created new star clusters, and possibly even led to the formation of new planetary systems. The evidence of this event is etched into the very fabric of the Milky Way, visible in the patterns of stars and the distribution of matter. More intriguingly, it suggested that our solar system, rather than being a native inhabitant of the Milky Way, might be an immigrant, a celestial traveler caught in the gravitational embrace of a larger galactic neighbor. This idea reshapes our understanding of the solar system's origins and its journey through the cosmos. It raises fascinating questions about the nature of our galactic neighborhood and the forces that have shaped it over billions of years. The story of our solar system is not just a tale of planets and stars, but a saga of cosmic migration and transformation, a testament to the dynamic and ever-changing nature of the universe. Galactic mergers are not unusual occurrences in the vast expanse of the universe. These cosmic events are more common than one might think, happening frequently across the billions of galaxies that populate the cosmos. Each merger tells a unique story of gravitational interactions and the relentless march of time. In fact, they are essential to the growth and evolution of galaxies. Without these mergers, galaxies would not be able to acquire the mass and material needed to form new stars and planetary systems. The merging process allows galaxies to rejuvenate, sparking new cycles of star formation and breathing new life into the cosmic structures. These events are slow, graceful dances on a cosmic scale, driven by the relentless pull of gravity. The gravitational forces at play are immense, guiding the galaxies in a delicate ballet that can span millions or even billions of years. This dance is a testament to the power of gravity, the force that shapes the universe. When galaxies collide, it's not a chaotic smash-up as one might imagine. Instead, it's a complex interaction where the galaxies pass through each other, their stars and gas clouds weaving intricate patterns. The process is more akin to a slow-motion waltz than a violent crash, with each galaxy influencing the other in profound ways. Instead, it's a drawn-out process, often taking millions, even billions of years to unfold. During this time, the galaxy's shapes are gradually distorted, their stars and gas clouds pulled into new configurations. The slow pace of these mergers allows astronomers to study them in detail, providing insights into the fundamental processes that govern galaxy formation and evolution. Stars, despite their immense size, are spread out over unimaginable distances. The vastness of space means that even during a galactic merger, the likelihood of direct collisions between individual stars is extremely low. This separation allows the stars to move through the merging galaxies relatively unscathed, continuing their journeys through the cosmos. This vastness means that direct collisions between individual stars are rare. However, the gravitational interactions between the galaxies can have significant effects on their stars, altering their orbits and sometimes even ejecting them from their home galaxies. These interactions can lead to the formation of new star clusters and other structures within the merging galaxies. However, the gravitational forces at play during a galactic merger are immense. These forces can stretch and distort the shapes of the galaxies, creating spectacular tidal tails and bridges of stars and gas. These features are visible evidence of the powerful gravitational interactions that occur during a merger, providing clues to the dynamics of these cosmic events. These forces can distort the shapes of galaxies, creating tidal tails and bridges of stars and gas. These structures are not only beautiful to observe but also serve as important tools for astronomers studying the mechanics of galaxy mergers. By analyzing these features, scientists can learn more about the history and future of the merging galaxies. This cosmic ballet can trigger waves of star formation as gas clouds collide and collapse. The gravitational interactions during a merger can compress gas clouds, leading to the formation of new stars. These bursts of star formation can light up the merging galaxies, creating regions of intense brightness and activity. It can also fling stars and solar systems out of their galactic homes, sending them hurtling through intergalactic space. These rogue stars and systems can travel vast distances, becoming isolated travelers in the void between galaxies. Their journeys are a testament to the powerful forces at work during galactic mergers. The discovery of these processes revolutionized our understanding of galaxy evolution, highlighting the dynamic and often turbulent history of the cosmos. The study of galactic mergers has provided valuable insights into the life cycles of galaxies, revealing the complex interactions that shape their structures and influence their development over time. It also opened the door to the possibility that our solar system might have been a part of such a dramatic event. The idea that our own solar system could have been influenced by a galactic merger adds a new dimension to our understanding of its history and evolution. It raises intriguing questions about the forces that have shaped our cosmic neighborhood and the potential for future interactions with other galaxies.